This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 77, a look at Ansys Motion, what it is and what's new at 2020 R2, along with a review of the news in the Ansys world. Welcome to this special post-Thanksgiving edition of our little podcast. I'm Eric Miller, one of the owners at PADT, and it's Sunday after Thanksgiving. Here in the U.S., we have this holiday, if you're not from the U.S., called Thanksgiving, where we eat a lot of turkey and watch a lot of football. It's generally an opportunity for families to gather. This year, less so, obviously, because of the coronavirus than most, but it was a nice 4-day break. I definitely goofed off a lot and didn't do this podcast on Wednesday or Friday or Saturday. So here we are Sunday recording this bit. But I do want to take this opportunity to express how thankful we are for making our living in the world of Ansys, which, when compared to other industries, has done just fine through this pandemic and even done its bit to help combat the disease. I also want to share with everybody how thankful we are at PADT for our employees, our partners, our customers, and yes, our listeners on this little podcast. I meant to do this Wednesday, like I said before the break, but here we are Sunday. So there's a little bit of noise in the background. Someone's making Christmas cookies in the oven downstairs in the kitchen. So my goal is to get this done in time to get the cookies when they're fresh out of the oven. So I may rush a little bit. I'm a little tongue twisted as well. I think I've been napping too much, so apologize for that up front. Let's get to our interview. Today, we're going to talk about Ansys Motion. This is a unique product in the Ansys family because it's actually a third-party tool integrated into the Ansys mechanical and workbench framework. As the name implies, it's used to model motion of assemblies, and it does it really well. Let's see what Jim Peters, who's our expert at PADT on this product, has to share about one of my favorite Ansys tools. Here we are, the Monday before Thanksgiving. I want to welcome Jim Peters joining me today to talk about Ansys Motion 2020 R2. Hey, Jim.
Hey, how's it going?
Good. So if you've listened to our discussions before on this topic, you know that I'm a huge fan of this product. And like Jim, in my youth, I used a competitive tool that was kind of the dominant kinematics and dynamics motion tool for a very long time, but now we've got a really powerful tool in Ansys Motion. So, how long have you been doing this kind of simulation, Jim?
A long time. 30 something, 30 plus years.
I think I went to Ann Arbor for training. Oh gosh, yeah. It was right after we started PADT. So it's been 1995-ish time period for me when I learned. And the name of the code is escaping me right now.
Atoms.
Atoms. Yeah. Thank you. Yeah. Atoms. Mm-hmm. Yeah. Atoms. And did some cool stuff with it, and then haven't really touched that kind of a tool until, we added the rigid body motion capability in mechanical, and now Ansys Motion. And let's start there. What exactly is Ansys Motion, and how does it different from, say, Ansys RBD?
Well, it's definitely a much more advanced tool. The rigid body dynamics tool is very efficient for rigid structures, and there is the capability through CMS to add some flexibility, modal based representation of some flexibility, but it's really kind of designed for just pure kinematic studies. Now, Ansys Motion is one that has 4 different solvers under the hood. You can do all rigid, or you can do some flexible bodies. You can do some modal bodies, or you can do what they call the meshless, which isn't really meshless, but it's
hidden mesh.
It's a hidden mesh behind the scenes capability. So the ability to be able to do full kinematic studies with flexible bodies is really where Motion stands out from other tools.
Right.
And primarily in long transients. If you're going to simulate a very complex, long duration transient, involves a lot of contact. If you're explicitly modeling gears and so forth, that is a very difficult proposition for a lot of codes. And the Ansys Motion really has a tremendous contact capability. It uses a implicit scheme, so it's very stable, and it's much faster than what you would get if it was an explicit scheme.
So. And that's kind of one of the keys, right? Is as you move these objects around, whether they're rigid or flexible, when things come into contact is when things get really interesting, and that's definitely been our experience, I think, is that it's been really good at that. And it's got a full capability of things like joints and connections and those sort of things, right?
Oh, yeah, absolutely. Yeah. And it has, some of the core functionality that you would see in any kind of kinematics code, but it has a lot of specialty toolkits.
Right.
For doing specific types of machinery, drivetrain and links and belts and all of those that would typically be a pretty laborious, type of thing to do without having some kind of way of automating that process.
Very cool. Very cool. It's got a nice user interface as well. From what I've played with it, really, really pleased with that tool. But what we're here to talk about today is what's new. And why don't you let's start off by what's your favorite new capability at 2020 R2 and Ansys Motion?
Well, they certainly are continuing to augment its capability of more complex gear systems and so forth. And so, there's really developments kind of being done on two fronts. One is into the main interface, and the other is exposing existing capability, toolkits, and so forth within a ACT extension for doing pre-processing using the mechanical environment that a lot of Ansys users are a lot more familiar with that structure and so forth. So it's kind of going in two realms there. More exposure to the mechanical environment as well as functionality being added to the base product as well.
Which is certainly something we've seen, and you and I have talked about with LS Dyna, right? In the, here's this other solver, but using the Ansys mechanical preprocessor to set up first kind of the basics of the model, maybe just the geometry and some basic things, and then over time more and more functionality exposed to where you can get further and further towards hitting the solve button within the mechanical interface. So like I know you haven't had a lot of time to play with it, but are we like for not a super complicated model, but for I know we've been doing a lot of solar panel actuation recently. So if you want to model one of those things, can you get most of it done in mechanical and hit the solve, or do you like 80%?
Yeah, the ACT extension was kind of introduced in 2019 R3, and that introduced some of the basic joint capability and so forth into the mechanical environment. And so what's come in 2020 R2 is really the exposure of some of those drive gear kits and so forth coming into that environment as well. So larger subsystems being able to be put together. But yeah, it's certainly those that are familiar with that kind of architecture of the workbench environment. You find that very, a very nice environment for setting up, joints and relations and so forth like that. I think one of the big things that's come on both indirectly through the ACT extension as well as in the standalone product is a plugin for space claim. So in the standalone product, you used to be able to just import external CAD, but there's now a specific plugin for space claim in
Nice.
the standalone tool to be able to port geometry directly in there. And that certainly helps in a lot of the prep of that, not having to rely on neutral formats and so forth to bring CAD in. So plus the ability to be able to do some quick modifications on geometry and then push it right back in again. It's really big.
Especially simplification. Yeah, that's a powerful capability. So that's actually a big step forward in the integration is getting SpaceClaim integrated with the standalone version. That's kind of huge. I didn't realize that was in there. Yeah, that's good. So of those new kind of, I don't know if you call them libraries or modules, power modules or toolkits, what's a really cool one that you've discovered in 2020 R2?
Well, the links kit is really cool. If you, trying to model chains and so forth like that. That's a very complicated process, and it would take a long time to set up contact and so forth. So that chain system, a lot of that functionality has been ported into the ACT extension. So that with the drivetrain are really nice.
That is very handy. And I actually remember doing that many, many years ago, trying to model it was actually a belt drive. And, coupling the drive shaft to the driven shaft using just a gear ratio was very straightforward to do. But I wanted to get the elasticity of the belt in there because it was causing some issues at certain resonances. And I gave up.
Yeah.
Now I guess that's a fairly straightforward process.
Yeah, that's a much easier process today than it used to be, for sure.
Yeah, all that contact was crazy. Very cool. So what else should we share with our listeners that's exciting?
Well, there's kind of four major kind of items that have come in 2020 R2 in the main product, and that's there's a CVT modeling tool, and that's really helps the whole combination of supporting pins and pulleys and placing connector models and being able to tension up that belt and things like that. So that's a new module that's in there. There's a ball screw modeling tool is in there as well. And
another thing that I did in Atoms back in the day for the space station actually was a ball screw actuator. Very hard to do. I'm so glad that this is in there now.
Yeah, and that's like I said, that's very detailed. It has all the helical patterns and fillets and balls, and everything's being modeled with contact. And so that's really a strong example of how that contact algorithm is working so well to be able to model something in full 3D detail like that.
So I want to go back to that because, in the past, the way you would model a ball screw like that, and if you're familiar with a ball screw, it's basically a nut on a threaded screw, but instead of thread to thread, there are ball bearings in the grooves, so you get a much more efficient and less lossy transfer of torque across the as you actuate. You can turn rotational motion into linear motion. And the way we used to do that is just write an equation that said, for this number of turns, you get this much motion axially. This is modeling the actual 3D ball screw.
Yes, that's right. Now, I have to mention I did model this in the RBD tool before we had access to this tool, and it was much more simplified and kind of worked, but it just highlighted how complex that contact is, and just being able to have it follow that actual pattern of the helical is pretty big.
So backlash is really important in an actuator like that, and being able to calculate that is going to be very, very. That's pretty exciting stuch.
Yeah.
Cool. So that's I got distracted on that one because that's an actuator that I'm very fond of because I used it very early in my career. So I like those. What's the other
The other one is a RV reduction gear modeling tool as well. Again, another kind of a subsystem of doing gear reduction capability and just being able to align different gears of different diameters and so forth together. There's a new cross helical gear tool for a non straight up engagement of gear teeth, and there's also a interface to Kitsoft. Now, Kitsoft is a very detailed gear analysis tool. It's out of Switzerland, I think, or out of Switzerland.
It's appropriate. It should be in Switzerland. If it's not in Switzerland, it should be. Yeah. For
so probably made it for very fine timepieces. But it's a very highly detailed, specialized tool for our detailed gear design. And so there's now an interface to Kitsoft to be able to bring those tooth profiles directly into Motion to be able to use those as a reference for your gear construction themselves. So,
again, a really almost a specialty that people have developed through the years is modeling those profiles accurately. And the fact that you can now do that using a gear design tool is an amazing step forward. That's great.
Yes, absolutely. And so those are the major tools. There's been some improvement in solving when you're dealing with multiple interfaces. If you're talking about a chain link or a multi-component belt drive where you've got simultaneous contact with several drive or follower mechanisms, that often can be a pretty difficult contact problem. And they've done some improvements to the algorithm, which is already doing it really well. And so they've been quoting, being able to reduce this one particular application of 5 or 6 different interface regions from 19 hours down to 3.5 hours.
Well, that's significant. Yeah,
that is significant.
Yeah, that's not. And is this using parallel or just algorithm changes, or did they share?
It's using primarily the algorithm change, just different way of handling those multiple engagement points.
Very cool. Yeah, because that can get very complicated very fast with some of the things that we're modeling these days. Cool. So that's really, really great. And before I ask for your final thoughts on it, just a reminder that you're doing a webinar to show off some of this stuff. Is it next week? The week after next week?
Yes. That's it. I think it's December 4th.
I think so. Yeah, usually on a Wednesday. Yeah. So if this has piqued your interest, as it should, because very few of us make things that aren't involved in some sort of a system assembly, and we need to model how that thing interacts over time. Kind of getting away from the assumption that everything has to be rigid, we can now put flexibility and model some of these complex systems much easier using this tool. So definitely check out that webinar, and I'll give the link in the follow-on. Just kind of as a conclusion, what would you like? I always like to ask this question. If you could go to developers and say, add this in the next release, what would you like to see next in the tool?
Well, it has a lot of the architecture of what's needed to do a lot of different things. So I don't know that I would have anything specific that I think it's lacking. It's more of a, just if you can run them more complex and faster, that's always
more efficient, more faster, better connection with mechanical, probably be a good one. And I've been very impressed with the speed of development as well of the team that's working on it. So very, very powerful. Well, cool. Anything else you want to add before we move on or finish up here?
Yeah, I think the biggest thing is when you look at the portfolio of all the Ansys tools that fit in this kind of arena of multi-body dynamics, just trying to understand where motion really sets itself apart. And I think the biggest one is just if your simulation environment, again, involves a lot of very complex contact, and the event itself is on the order of minutes or hours.
Okay. Yes.
This is a tool that can practically do that. I mean, there's some other tools that theoretically can do that. Some will do it better than others, but it will likely be significantly longer and much more difficult to solve problems like that. And that's really where this product shines. And so, just trying to identify its sweet spot of application.
Great. Yeah, that's a really good place to finish up, because I think it's really important to understand that. And oftentimes, when we only have hammers and screwdrivers, we forget that there's saws out there, and maybe a saw is the right for the right problem. It's the right tool, and this is definitely the right tool for the right problems. And I'm excited about seeing more and more applications of it, and more system level modeling that enables this. And of course, you can take the loads from this, right, and import them into mechanical and use them for component level simulation as well, which is really cool. And if you want to go down the road of co-simulation, you can use what do they call it now? I want to call it digital mockup, but Twin Builder. Twin Builder to couple all these things together.
MATLAB and other hydraulic simulators.
A lot of cool capabilities out there. Well, thank you, Jim. As always, I hope you have a wonderful Thanksgiving. This will come out after Thanksgiving, so stay safe out there, and don't eat too many leftovers.
All right.
Thanks.
Sounds good. All right. Take care now.
Bye. So do check out Jim's webinar on Wednesday, December 2nd at 11 Phoenix time. As always, you can go to brighttalk.com and search for PADT Ansys Motion to find it, or you can go to our website, www.padtinc.com/events, where you can find all of our events, including these webinars. And I believe this is the last one for 2020. Maybe there's one more before the end of the year, but I think this is it. So we want to thank everybody for attending those throughout the year. This is usually where we do our commercial, but I'm not going to do a commercial this week. I'm just going to give another thanks to you and to everyone who listens and is part of the PADT and Ansys families. We do appreciate all of you. So let's look at the Ansys stock. It's at $330.41, which is up on Wednesday when the market closed before the Thanksgiving holiday, was up 2.34% for the day. The market had a big surge, and there were some nice gains right before the break. Mostly because news of the vaccine getting further and further and closer, further along and closer to hopefully getting injected into people's arms. So we're excited about that. The S&P 500 for the year to date is up 12.62%, and Ansys is up 28.36%. Now, if we look at other stocks in the sector, the ones that I usually track are PTC, Altair, and Autodesk. They're the closest to what Ansys does. And they're actually doing a little bit better year to date than Ansys, which is unusual. PTC is up 45%, Altair 48%, and Autodesk also 48%. I'm not sure why. Autodesk and PTC do a lot more than just simulation. Of course, they're mostly CAD companies, or what they like to call themselves PLM companies. And Autodesk has an even broader range of products and broader range of industries. Altair was a bit of a surprise to see them go up as much as they did, but I'm sure there's a reason for it. Maybe between now and the next podcast, I'll do a bit of research and find out why that is happening. But it's good to see the whole sector up in general. In the world of Ansys news, and speaking of PTC, they announced an even tighter integration with Ansys solvers. That was the big Ansys news in the last 2 weeks. Basically, what it looks like is that in Creo, which is the CAD package, what they call the CAD package now, you could run Ansys Discovery for a little over a year now, I think, and now it looks like you can have access to the Ansys structural solver inside Creo. So it's using the Creo interface, which you're used to if you're a PTC user, but you can set up and run and post-process your models in that interface, but the actual solve is done in probably APDL. I'm not quite sure if it goes through mechanical first or if it goes straight to APDL. We'll have to definitely research that. But it's doing thermal, structural, and modal analysis. They call it, the product is called Creo Ansys Simulation. You can also, one of the things that I learned is you build a model there and it works fine, but you want to do more sophisticated simulation than is supported in the Creo interface, just punch out and it'll export the model into Ansys Mechanical. So you can go right into Ansys Mechanical. So if you are a Creo user, I really strongly recommend that you search for PTC Ansys Simulation. And on the PTC website, there's a press release about this. And more importantly, there's a video that actually shows how it works. Really nicely done. It's not the first time that we've seen interfaces to the Ansys mechanical or mechanical APDL products in the PTC product family, but it's definitely a more advanced version of that and really well done. Definitely worth a look if you use both products. In the world of, that's all we have for Ansys news. In the world of PADT news, we announced that PADT is growing in the area of 3D printing. And in doing so, we, especially in metal, we just added an EOS M290 machine. And the official announcement that Kang Xu, who's a former ASU and University of Louisville professor, is now on our staff as a senior researcher in the area of metal additive manufacturing and design for additive manufacturing. So we're really excited about that. It's a big step forward for us. We've been in metal for a long time, but the addition of this machine, which is kind of the most common machine out there for metal additive, and Kang, who's a true expert in the field, is going to take us to the next level. So look for that to bleed over into the world of Ansys. Kang is using the Ansys additive product right now. In fact, we were doing some benchmarking just Wednesday before the holiday break to see how fast it runs on various machines. So hopefully we'll get a chance to get him on to talk about that in the near future. So very exciting news there. Publication-wise, I picked out 2 blog articles from the Ansys blog. The first one is really well done, how HVAC simulation can improve safety in public spaces. Of course, we need to keep moving the air around to keep the virus, which is an aerosol, from getting into people's noses. And this is a really good model. Really look at how you can model that in the Ansys products. And then the second one that I really enjoyed was simulate flight control systems with embedded software in the loop. And although this is about flight control systems, it's a good example of how you can use SCADE to do embedded software and Twin Builder, which is our system modeling tool, to look at how to model complicated control systems where you've got the actual embedded software in your simulation loop. So very, very cool there. Nothing new on the Ansys blog. Let's take a look at the upcoming events in the world of PADT. So I'm going to go to our website to see that. Go to padtinc.com/events. And we've got 3 on Wednesday. The first one is going to be something we're doing with Ansys called Ansys Mechanical Level Up. So the idea is to take a look at doing more with Ansys Mechanical. It's a virtual event that Ansys is sponsoring from 10 a.m. to 2 p.m. So it's a good 4-hour event, and that's Eastern time, by the way, 10 a.m. Eastern time. So do check that out on our website, on our event page. And then we're doing, Jim's going to talk about multibody dynamics in Ansys Motion. And then in the evening, I'll be hosting the final Arizona Tech Business Networking event, our 9th one. Since this whole thing started, I thought I'd do 3. We'll probably do, gosh, who knows how many more if we're doing one a month. Probably 2, at least 2, if not 4 more of these things. But the last one of 2020 is going to be on December 2nd at 5 p.m. Mountain Standard Time. That's Phoenix time. And anybody that's interested in technology in Arizona, you don't have to be in Arizona, you just be interested in it in Arizona, is welcome to attend. It's a really fun event, and we're looking forward to it. Also, holiday events coming up with the Tech Council. I'll be at the Tucson After 5 Holiday Text Mixer, which is virtual on the 9th. And then our big Tech the Halls virtual holiday mixer, which is on the 16th of December. I will also be attending that. And that's from 3 to 5 on the 16th of December. And that should be it for the rest of the year. What a year it's been. We'll be doing one more podcast at least. Let me take a look at the calendar because, this will go out on the 30th. So, we'll probably do one more podcast, if not, and then a 2020 sum up before the end of the year if I can get everybody together. So I want to spread holiday cheer to everyone and thank everybody for attending. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in and spread the word. Please subscribe to the podcast itself as well. And don't hesitate to reach out at podcast@padtinc.com. And so I hope everybody had a wonderful Thanksgiving. And thank you for listening through this tongue-twisted version of our podcast. And we will talk to you in 2 weeks. Thank you for joining us for the All Things Ansys podcast, episode 77. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only, and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time. A little postscript. The cookies, outstanding. Ginger snaps. Really, really good. Everybody have a great holiday season.